All right, let's talk about one of the most maddening, pull-your-hair-out challenges for any developer working with GenAI, debugging in production. You know what I'm talking about, chasing ghosts in your logs. Well, today, we're going to lay out a framework to bring some serious order to all that chaos.
Does this sound familiar? I'm going to bet it does. This sentence, right here, is the bane of our existence as engineers. It's that one bug report that pops up, ruins a user's day, and then poof, it's gone. Just vanishes the second you try to track it down. A total phantom.
And that's the real question, isn't it? It feels impossible. You're like a detective showing up to a crime scene, but all the evidence, all the fingerprints, they've been wiped clean. Without reproducibility, you're not debugging. You're just guessing. And that's not engineering.
But here's the thing. These vanishing bugs, they aren't some kind of black magic. They are an expected outcome when you're working with systems that have randomness baked right into their core. So first things first, let's understand where all this chaos is coming from, because you can't control what you don't understand.
Think of our crime scene again. It's got 4 main ways it gets contaminated. First, the model's responses are probabilistic. That means you can ask the same question twice and get 2 different answers. Then you've got automatic retries, which silently cover up the original failure. Streaming can cut off a bad response halfway through, so you never see the full error. And sometimes, the provider themselves introduces tiny changes we can't even see.
So this is the most crucial mindset shift you have to make. When you see a weird one-off failure, your first thought shouldn't be, I've got a bug to fix. No, it should be, I have just witnessed a random or stochastic event. You can't fix randomness, but what you can do is control the conditions to see if a real, honest-to-goodness bug is hiding underneath all that noise.
And that brings us to our turning point, the big idea, the replay rule. This is the one principle that lets us turn that chaos into a controlled scientific investigation. It's how we separate the random noise from a genuine fixable bug.
This rule is so fundamental that we're calling it the second rule of debugging GenAI. Now, why the second rule? Well, the first rule is just capturing the failure data. But this rule, this is the one that actually lets you solve it. This is the key that unlocks the whole case.
And here it is. So simple, so powerful. It's an absolute. Before you touch a single line of code, before you even think about tweaking a prompt or shipping a hotfix, you do this. You replay the exact identical request that failed. No ifs, ands, or buts.
And let's be crystal clear on what unchanged means. It means identical. The exact same prompt, character for character. The exact same context you pulled from your vector DB, the same model, the same version, and every single one of those inference parameters, temperature, top P, you name it. The second you say, oh, I'll just make one small change, you've contaminated the crime scene. Game over. The investigation is invalid.
Okay, so we have our rule. Now let's get practical. Let's build the workflow. How do we actually set up a clean, totally deterministic replay environment? How do we properly secure that crime scene?
It's really just a 3-step process. First, we're going to eliminate all the variables, everything that's introducing randomness. Second, we run our replay using the pristine evidence we captured from the failure. And third, we make a super important black and white decision that tells us exactly what to do next.
So, step 1 is all about prep. For your replay environment, you must disable streaming. You need to see the entire, complete, blocking response from the model, not some partial answer that got cut off. And you absolutely, positively have to disable automatic retries. Now look, retries are fantastic for production resilience, but for debugging, they are poison. They hide the very failure you're trying to hunt down. We need to see that very first attempt, the one that actually blew up.
Now, for step 2, you take that immutable artifact you logged, that beautiful, complete request payload with the exact prompt, context, and all those parameters, and you replay it. Then, and this is the crucial part, you replay it again. Why twice? Because if you get a different result on that second replay, you've just proven it. You're dealing with randomness, not a consistent, deterministic bug.
And this brings us to the climax of our investigation, the moment of truth. After running the replay, we get to interrogate the system. We force it to give us a straight answer. Are you a real, consistent bug, or were you just a ghost in the machine?
This table right here, this is your whole playbook. If the failure is not reproducible, you're on the left side. Your diagnosis is just sampling variance or some other noise. The right move is to mitigate it. Maybe you lower the temperature to get more predictable outputs or add some output constraints.
What you absolutely do not do is start rewriting prompts or shipping frantic hotfixes. But if that failure is reproducible, if it happens every single time, congratulations. Now, and only now, do you have a real bug to fix. Your job is to start isolating where it is in the prompt, the retrieval, the tools, whatever.
You know, following this discipline, it's about so much more than fixing just one bug. It's about fundamentally changing how your team approaches development. You move from chaotic guesswork to structured, reliable engineering.
Just look at the contrast. Without this process, teams are just chasing ghosts. They fix symptoms, but the root cause is still there. Regressions pop up constantly, and slowly, trust in the whole system just falls apart. But with a deterministic replay process, every single production failure becomes a valuable asset. It becomes a test case. Your incidents literally build your regression suite for you, making your system stronger over time. Debugging stops being this frantic art and becomes engineering again.
Let this one sink in, because it's everything. If you cannot reproduce a failure under controlled, deterministic conditions, you have not found a root cause. You've simply observed a random event. So you log it, you monitor for it, but you don't pretend you fixed the bug. This discipline alone will save your team countless wasted hours. So here's the final thought to take with you. Yes, the GenAI systems we build are probabilistic by nature. That's their power. But our approach to debugging them in production must be deterministic. Always replay first. That is how you turn chaos into code. Thanks for tuning in.